All right, here we go. You should have got these instructions from class. If you didn't, take a time to actually copy them down. Make certain you understand them as we go through. So the first set for mirror concave, we worked through in class. We didn't have enough time to get through convex lenses, but we're going to try and do that today. So if you look down, if you didn't get these down, go ahead and pause the video. Make certain you actually record them, and then actually use kind of like a sketch like we did in class. And we're going to go through one example that I'm going to show you so you understand the instructions on how to do the Leiden diagrams, but the good news is the calculation you should already know. So first one, start at the line at the top of the object, draw the parallel to the floor. This is just like the previous version, except when you hit the mirror, you go to the focal point on the other side of the mirror. That's where you need to know the difference between concave and convex. Okay, so far focal point and then beyond. So just like a light diagram, keep drawing that line further. So then line 2, you start at the line at the top of the object through the focal point behind the mirror. So you literally go all the way across the mirror, through the focal point, and then continue on. So when you get to the far focal point after the mirror, you make dashes. And this will again make more sense as we do this a little bit differently on this one because it's a video. So then the last, draw the line at the top of the object through the center of the curvature through the mirror. Okay, so what does that look like when you do it in practice? It looks like this. So let me see if I can get this computer to work with us. There we go. Shrink that down a hair. That'll work. So line 1, just like we did before, line 1 goes from the top of the object to the mirror and then through the far focal point. See how it makes that nice dotted line? Now here's the reality is it's a mirror, so it's going to reflect the light away from it. But the line you use is down through the focal point. Okay? Now obviously, if it goes this way, it's going to reflect back that way. Line 2, start at the top of the object through the focal point. So if you see number 2 goes down and aims at the focal point. This is where it gets a little bit harder for the convex mirrors. That's why we start with concave. At that right point where you actually cross the mirror, you're going to make a parallel line. Okay? So again, for line 2, you start at the top of the object, aimed at the focal point, then you make that parallel line. And number 3, you actually start at the top of the object. It's really hard to see. And you go all the way down to the center of curvature beyond the mirror. So hopefully you can see that. I'm going to blow this up so we can actually take a good look at it. So again, 1, you hit the mirror, you aim at the focal point, but light bounces off. Line 2, you aim at the focal point, and then it bounces back parallel. And line 3 is the easiest. It goes from the top of the object through the center of the curvature on the far side. Take some time. You should practice already, hopefully, 1 or 2 of the other for the concave mirrors. At the back of your packet, you should have 1 or 2 for convex. Try them, see what you're doing. The big thing for today is at home, try and go through a few of the diagrams and see if you can follow the instructions. If you can't, don't get really frustrated. Try a little bit of practice and then go from there. If you get really, really frustrated, stop, try some of the calculations and then work on the calculations. So just like the previous example, so you have the exact same thing. So in this case, a convex mirror, focal length of 8 centimeters, a 2.5 centimeter tall object, measured in pencil, is formed behind the mirror. Find the position of the object. So in this case, they give us the focal length, the image height, and then the distance to the image. So write down what we have. Because it's behind it, it's a negative 8 centimeters. Q is -4, and H prime, the height of the image, is 2.5. So there's lots of ways we can do this. Let's do this the way they want. So draw the diagram, and this is what it is. We don't know the distance to our object. We know the focal length is -8, the image length is -4, and C is somewhere out there. So use our equations we've already got. They love to reorganize them. I hate that. Do it. I would say keep them in the original form, plug them in and solve them. You know that's the way I like to do things. Keep it simple because me and algebra have problems from time to time. So, first part, calculate this version. You should say 10 centimeters. So the object is 10 centimeters in front of the mirror. Doing the math, this should work out. Again, same method as the concave mirrors, just a little different. Now, magnification. This will give us the height of that object. So again, m equals negative q over p, negative 4.4. The magnification is 0.4. The other way to solve this is this equation that you haven't seen. So now you have negative 10 over negative 4 times your 2.5. And that'll give you this distance. The other option is to sit there and say, okay, in the original problem, they gave you a height of 2.4. This is the image height, 2.4. So, 2.5 times 10 divided by 4 should give you 5.53. And I'm going to check one more problem. Yes, so questions on those. That's really what you need to look for. And we'll get through parabolic mirrors. I want that to be the focus. So we're going to stop there. We'll continue on with calculations, and then we'll talk about lenses later. So hope you have a good snow day. Take a look at the problems I've set. Or the only real problem I want you to have is doing the ray diagrams, so go from there. Just the ray diagrams.